Fluid coding and AI. Leanstral 1.5 looks like a math model at first glance, but the more interesting question is developer-shaped. Can a proof agent become a practical bug-finding companion, or is this still mostly a research demo with better branding? Mistral released Leanstral 1.5 on July 2, 2026. The public shape is unusually developer-friendly for a formal verification model. Apache 20 waits on Hugging Face, a model card listing a 256K context window, and a $0 hosted API route. The model is 119 billion total parameters, with about 6 billion active. The model card says 6.5 billion active, so I am going to use the safer phrase about 6 billion. The easy video here would be a benchmark recap, mini F2F, Putnam bench, FAT, big proof numbers, everybody nods, nobody changes how they ship software. That is not the useful question. The useful question is whether Leanstral can help with code that has crisp invariants, codecs, parsers, ring buffers, auth rules, rounding logic, migration checks, the kind of code where one edge case can quietly ruin your afternoon. Mistral's best concrete example is not exotic. It is an integer bug in a Rust varinteger library. The reported issue was a zigzag decoding sign function. On the maximum unsigned 64-bit value, adding 1 overflowed. In debug mode, that could crash. In release mode, it could silently corrupt the result. That is exactly the kind of bug tests can miss when the usual examples are small, friendly numbers that behave nicely in front of guests. Here is where my expectation changed. Leanstral is not only trying to write proofs after a human has done all the formal methods work. Mistral's code verification pipeline used Aeneas to translate Rust into Lean, asked Leanstral to infer intended properties, and when a proof failed, it tried to prove the negation. That last step matters. A failed proof is usually ambiguous, but a proved negation can start looking like a real counterexample. The agent story gets more practical when you add Lean's language server tools. Lean LSP MCP exposes file contents, diagnostics, proof goals, term goals, hover information, completions, snippet compilation, and multi-attempt proof screening. It can also call theorem search tools like Lean Search and Lugal. That means the loop is not just ask a model for a proof and hope. It is closer to a compiler-driven repair cycle, where every failed attempt leaves structured evidence behind. Imagine a tiny Rust ring buffer. It has push, pop, length, capacity, empty, and full. The invariants are boring in the best possible way. Length never exceeds capacity. Head and tail stay inside the buffer. Pop returns items in first in, first out order, and push never overwrites unread data. Now plant the classic bug, head equals tail means empty, unless you forgot a length field, in which case full and empty can become the same state. That is not a vibe. That is a spec problem. A unit test can catch one sequence. Push one item, pop one item, assert it matches. Great, do that. Property-based testing can generate many sequences and find weird state transitions if the generator and oracle are good. A Lean proof asks a different question. For every valid state, does the invariant still hold after this operation? That is stronger, but it is not free. Somebody still has to state what valid means, and that somebody is usually you. The painful part of Lean is often not the idea of the theorem. It is the 1,000 tiny proof repairs after Lean says, politely but firmly, no. Leanstral 1.5 is aimed at that pain. Long context helps it keep the file, the goal state, failed attempts, and nearby lemmas in view. LSP tools give it feedback. Safe verify style checking helps keep the final answer honest. The model is not the authority. The checker is. Mistral reports very strong proof benchmark numbers. Mini F2F is listed at 100% on validation and test. Putnam bench reaches 58.7 solved out of 672 at the highest reported budget. FATH is 87% and FATX is 34%. Those numbers matter because they show Lean skill, but they are still mostly proof benchmarks, not a direct answer to whether your team should run this against a normal library next sprint. The more useful developer evidence is the code verification case study. Mistral says it tested 57 Rust repositories, flagged 47 violated properties, found 11 genuine bugs, and identified 5 bugs that were previously unreported on GitHub. That is genuinely interesting. It is also not enough public detail to estimate precision, false negatives, selection bias, or human triage time. In other words, useful signal, not a finished buyer's guide. The public FLTEval sample adds another useful reality check. In the fetched artifact, 162 instances were submitted, 109 resolved, 109 resolved. That is impressive for hard, lean repository tasks, but it also means most tasks in that sample were unresolved. So the right mental model is not agent solves verification now. It is agent makes a hard proof engineering loop more productive, especially when the problem is shaped well. For Rust, the story is relatively concrete because Aeneas can translate Rust through intermediate models into lean backends. That does not mean every Rust repo is ready. It means there is a path. For TypeScript, the checked sources do not show a comparable first-party translation workflow. You can still model a sorted unique set or business invariant in Lean, but that is more manual. So the fit today is narrow, small, sharp modules where the spec is worth writing. My verdict, Leanstral 1.5 is a serious proof engineering agent release, not proofs for everyone. If you maintain codecs, parsers, state machines, financial rounding, migration logic, or security-sensitive rules, this is worth watching and maybe testing on one contained module. Pair it with unit tests and fuzzing, not instead of them. If you want a drop-in CI bot that reads an arbitrary app repo and files trustworthy bug reports, we are not there yet. Leanstral does not make verification effortless. It makes the first believable version of an AI-proof repair coworker easier to imagine. If this helped you separate proof agent substance from launch day noise, like the video and subscribe to Fluid Coding and AI. I will keep testing where AI coding tools actually become useful and where they are still wearing a lab coat.